So this whole unit's been about quadrilaterals. This whole unit's been about quadrilaterals, four-sided figures. And so the very first day, all the videos already posted up. We talked about just the general facts about quadrilaterals. Four sides, we talked about consecutive sides, opposite sides, consecutive angles, opposite angles, everything like that. So quadrilaterals. And then we got a little bit of detail. We said, okay, well, what happens if there's two distinct congruent consecutive sides? Well, if that happens, if you show what your quadrilateral, then it's a kite. We talked about that. Then we said, well, what if you have one pair of opposite sides that are parallel? That's a trapezoid. Then, if you have another unique case would be, well, what if these sides were congruent? The sides that are not parallel, they're called the legs. Then we said that that is an isosceles trapezoid. Now, we've already taken notes over these. There's already videos posted. We've already taken a quiz over these things. Okay? So this is good and true, and we have learned this material. How many pairs of parallel sides do kites have? How many pairs of parallel sides?
None.
None. There's none. No sides are parallel whatsoever. So I'm going to put no sides parallel. What about trapezoid? How many pairs of parallel sides? There's one. There's one pair of opposite parallel sides. This is going to be one pair so I just use the symbol for parallel. One pair of opposite sides that are parallel. I'll just write it out. Rather be safe than sorry. One pair of opposite sides that are parallel. Well, the new quadrilaterals we're going to talk about today, all four of them can be classified as parallelograms. If kite had no sides that are parallel, trapezoid had one pair of opposite sides that are parallel, how many sides do you think a parallelogram has that are parallel? Both. Okay, so both pairs of opposite sides are parallel. So, we're going to draw a new arrow over here. And so this is our next type. This is our next quadrilateral. And we're going to draw just a basic representation of a parallelogram. And I'm going to draw it so that it's clear that this does not have four congruent segments. Okay? I'm just going to make it clear that that's not the case. But what we do know by definition is that both pairs of opposite sides are parallel. Both pairs of opposite sides are parallel. So this is what I need you to write down next to this shape. So I have a quadrilateral, it's a four-sided figure, and I've drawn in those arrows that are showing that both pairs of opposite sides are parallel. So the first thing you need to write down, and we're going to have to write a little small, and you can put facts about it on both sides, but first I'm going to write DEF, that stands for definition. The definition of a parallelogram is that it has both pairs of opposite sides are parallel. Okay? It's a quadrilateral. It's a quadrilateral with both pairs of opposite sides parallel. Definition, quad, with both pairs of opposite sides parallel. And then we talked about this. Kites have 0, trapezoids have 1, so the parallelograms have 2 parallel. Two sets of parallel sides. And so looking at this list, the next property that you need to write down is that the consecutive angles, we don't need to see kites and trapezoids anymore. The next thing we're going to write is that all four pairs of consecutive angles are supplementary. That's our next fact. So consecutive angles are supplementary. You should be able to identify what your consecutive angles are. We'll do this in a different color just so we know what's going on. Consecutive angles are supplementary. What does supplementary mean? Add it to be 180. Okay? How many pairs of consecutive angles are there in every quadrilateral? How many?
4.
4, right? 4. Every single quadrilateral has 4. So all 4 of those pairs, it's weird not having this here. No, sorry. Anyways, all 4 pairs of consecutive angles are supplementary. And it's an easy proof because if you have parallel lines being cut by a transversal, same side interior angles are supplementary, just like we did with the trapezoid. But now we can say all of the consecutive angles are supplementary because both pairs of opposite sides are parallel. The next fact is that both pairs of opposite sides are congruent and both pairs of opposite angles are congruent. So what's our next fact? I'm going to combine, on the board, I'm going to combine the red and the blue into one. I'm going to say that both pairs of opposite sides and angles congruent. So if I wanted to mark in my diagram up here, I could say that this is congruent to that, and I would say that that is congruent to that. I know that my opposite sides are congruent, and I also know that my opposite angles are congruent as well. These are just the facts of a parallelogram. And the last one is that the diagonals bisect each other. That the diagonals bisect each other. And so I'm going to write that underneath. We'll write that underneath here. Diagonals bisect each other. Okay, then there are two special types of parallelograms. There are two special types of parallelograms we're going to talk about. So, from here, it stems from here. What if I have a parallelogram, but all of the interior angles are congruent? Okay, so first, let's just kind of unpack that. If you have a quadrilateral that has all the interior angles are congruent, who can tell me what the measure of each one is? It's a quadrilateral with 4 sides. Then each interior angle would have to be what measure? Is that Harley?
90.
90 degrees, very good, sir. Making them all right angles, okay? Because for any quadrilateral, the 4 interior angles add up to be how much? 360. You get that by doing that n minus 2 times 180. So 4 minus 2 is 2. 2 times 180 is 360. So your 4 interior angles will always add up to be 360 degrees in a quadrilateral. So if that has to be split up evenly 4 ways, that means each one has to be 90 degrees. So what do we call a parallelogram with all congruent angles, with all right angles? Rectangle. Okay, we don't know anything about the sides yet. Rectangle. And so you guys have heard of this before. Rectangles. Now, because rectangles are parallelograms, means all of this stuff is true for rectangles. All all of these facts are true for rectangles. All 5 of these things are true with rectangles. But what we're going to add to the list is